Hi there and welcome to this e-tool video. I'm just going to quickly run through some of the new functionality that we've introduced with templates around adding operational energy. So previously in e-tool, to add operational energy you needed to actually know the megajoules per annum that a particular energy device was responsible for. We've made that a lot easier now. So for example, we've got templates for heating, cooling and ventilation. So if we delete this thermal control entry out, we can now select the template wizard and under services, type in Hvac. We can see we get a big list of different heating and cooling methods. So these are all residential. This is residential building that we're seeing here. So we'll choose the residential split system, which is a standard air source heat pump for heating and cooling. And we're just going to select, perhaps in this building, it's a 4-bedroom building, so there may be 2 or 3 actual air conditioning units. Add that to our design. And you can see that's actually added some heating and cooling energy, as well as the embodied impacts of the heating and cooling devices itself, so the materials, etc., in the heating and cooling device. If we go back and have a look at the detail of the operational energy, it's still actually giving us the annual energy use per for the building in megajoules, but there's this formula here that gives us that result, and it actually updates depending on the size of the building. And then all these items here, you can edit those yourself. In future they'll probably actually be listed as items for the design, but to understand what they mean, if we go to the template details and we expand this box here, you can see that the formula is pretty well documented, and we can see here that the energy use is a function of the condition space times the in this case is the heating energy, so it's the heating load of the building divided by the COP, and then this here is an adjustment of the coefficient of performance, or the COP, based on the ambient temperature. So if we now go back into, and I might just open this in a new tab so we can flick back. So the assumptions we've made here in the heating energy for this building is that it has a heating load of 50 megajoules per metre squared. The coefficient of performance of the heating device is 4. The temperature that we're trying to achieve inside the dwelling is 22 degrees, and the external temperature while we're heating 7 degrees. So if you're in a more extreme climate, and maybe you're trying to heat at 0 degrees Celsius, and perhaps your building has a greater heat load as well, so it might be 100 megajoules per metre squared, but you've managed to source a heat pump that has a rated coefficient of performance of 4.5, then you could update those values and it would automatically update the result in megajoules per metre squared. And this is the electricity demand, so it takes into account all those factors. A couple of things to be aware of. If you now we loaded up 3 air conditioners into this building. The heating load just relates to this information here. It does not relate to the number of air conditioners. It relates to the conditioned space of the building, and many of the heating and cooling devices, if we just go and have a look at that list, they're only actually heating or cooling. So that one that we've just looked at the example, it's actually heating and cooling, but most of these, so this is a gas heater, this is an evaporative cooler, so sometimes you'll be entering in one template for your heating and cooling, and other times you'll be entering in two if you specify some of these other HVAC methods. Where we'll be taking this is we'll be adding HVAC templates for commercial buildings as well, and yeah, we should have a fairly comprehensive list there. Thanks for listening.